Measure airflow CFM quickly and accurately using the HVAC temperature rise formula to verify system performance and safety. Start by measuring return and supply air temperatures at least 3 feet from the grill to avoid short-circuiting. Take the average of 3 readings on both sides and record them. Use a calibrated thermometer with at least 1/10 degree accuracy and log ambient temperature and wet bulb if humidity is high, because density corrections matter for precise cubic feet per minute calculations. Calculate temperature rise as supply minus return, then apply the formula CFM equals heat input in British thermal units per hour divided by 1,200 times the temperature rise, making sure the heat input number reflects measured burner output or nameplate input corrected for combustion efficiency. Do not use gross input without efficiency adjustment. If using electric heating, use measured kilowatts converted to British thermal units per hour by multiplying by 3,401, then divide by 1,200 times the rise. Always verify blower wheel diameter, motor sheave settings, and static pressure before concluding the CFM. One misaligned sheave or plugged filter can make the calculated CFM meaningless. When you suspect duct leakage, supplement the temperature rise CFM with a blocked duct test or a pitot traverse in the main trunk to cross-check results and identify imbalanced locations. Document all test lead connections, exact sensor locations, and the duration over which averages were taken so anyone can replicate the test. This reduces liability and improves commissioning handoff quality. Before leaving the site, perform a functional sequence and monitor return air temperature for at least 10 minutes to confirm the system stabilizes and the measured performance holds under operating conditions. One of the most common mistakes is using nameplate heat input instead of actual heat output when calculating airflow CFM, which produces inflated or deflated CFM values. Fix this by measuring combustion efficiency with a flue gas analyzer or by using manufacturer performance tables and applying the correct efficiency factor. One of the next frequent issues is poor sensor placement and single-point readings that create noisy data and incorrect temperature rise. Fix this by averaging multiple readings at standard distances from grills, securing probes to avoid airflow disturbance, and logging for a stable interval. One of the other typical problems is leaving test wiring, temporary jumpers, and open panels in place after the test, creating safety and control sequence faults. Fix this by following a strict reset checklist. Disconnect all test leads and temporary jumpers. Restore factory wire routings. Torque terminal screws to specified values. Replace and secure all panels and covers. And power up the system following manufacturer sequence and lockout tag procedures. BigHomeProjects.com lists vetted HVAC contractors and resources specific to airflow testing and system commissioning. Use the directory to find qualified local technicians who understand temperature rise CFM calculations and to help contractors receive targeted leads for reliable homeowner projects.